This mini lecture talks about changing from a fraction into a decimal. And the first thing to think about is that fractions are another way of writing division. So fractions are division problems. So if we look at this first fraction, 4 divided by 5 is how we would say this. We're going to write it as 4 divided by 5. And when you look at this, you already see what could be a problem. 5 is already bigger than 4. It's not going to fit in even one time. So by putting a decimal behind the 4 and directly above it in the answer, that will let me add a 0, because 4 and 0/10 is the same thing as 4. And now I have enough digits to be able to divide the 5. So 5 would fit into 40 a total of 8 times. 8 times 5 is 40. And I subtract and don't have a remainder. So since I have a remainder of 0, that means I'm all done. And 4/5 would be the same thing as 8/10, or you could refer to it as 0.8. This next one's going to take a little bit more work to do. It's the division problem 5 divided by 7. And again, 7 won't fit into 5 even once, so we're going to use the decimals and add our first 0. And we're going to need a few more zeros, so I'm going to put some down to start with. Okay. So when 7 goes into 50, it fits 7 times. 7 times 7 is 49, and 50 minus 49 leaves us a remainder of 1. So by writing my remainders up here next to my zeros, that process is called short division. If you have not yet watched that mini lecture, if this part's confusing to you, you can go back there to see how short division is done. So now I'm dividing 7 into 10. That'll fit 1 time with 3 remaining. And 7 will fit into 30 4 times with 2 remaining. And 7 into 20 goes 2 times with 6 remaining. And then 7 into 60 is 8 with 4 remaining. And 7 into 40 is 5 with 5 remaining. And 7 into 50 is 7 with 1 remaining. So we're going to stop here for a minute because I want to point out something that's happened. When we first started the problem, we were dividing 7 into 50, getting 7 with a remainder of 1. And if you look down here, we have the same thing happening. 7 was divided into 50, and we had a remainder of 1. So what that means, since we're always adding only 0, is that we've had a pattern start here that is just going to continue. If we continued dividing, it would fit 1 time, then 4, then 2, then 8, then 5, then 7 again, and then the pattern goes on. 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, indefinitely. So the way that we're going to write this answer is that 5/7 put down 1 occurrence of that repetition, 7, 1, 4, 2, 8, 5, and then by putting a line over the top of it, that's the math symbol to say that 5 really isn't the end of the division, that's just the end of the repetition. And then that same sequence of 6 numbers repeats indefinitely. So the decimal version of 5/7 is going to be the repeating decimal of 714,285 millionths. How's that for a mouthful? Our last example is looking at a mixed number, and I'm going to show this one 2 different ways. Okay? One option would be to take the fraction, or the mixed number 2 2/3, and change it into its improper fraction form. 2 times 3 is 6, plus 2 more gives us 8/3. Now we have a division problem again. In this case, the problem says 8 divided by 3. And 3 fits into 8 2 times with a remainder of 2. And 3 fits into 20 6 times, again with a remainder of 2. And once again, you can see that that pattern has come back, that we put 3 into 20, got 6, 3 into 20 again, got 6. So those 6s are going to repeat indefinitely. So our way of writing our final answer then is 2 6/10 with that repeater line over the 6. Our other option for doing this problem would be to take the fraction 2 2/3 and separate the whole number from the fraction part, because there are 2 wholes, and even when we write our decimal version, there will still be 2 wholes. It's just the fraction part that we need to turn into the decimal. So if we do it that way, we're going to be looking at the division problem 2 divided by 3. Put in our decimals, and you'll see that the pattern starts just like it did above. So to bring those 2 parts of the answer down below, we're going to end up with a 2 plus 6/10, which is the same thing as 2 6/10 with the repeater over the 6.